Good morning to one and all present here. Today we are going to see about the block 5, that is about clustering and its methods. So we are going to overall see about the cluster analysis, the type of cluster analysis, and the class categories of clustering methods, major clustering methods, and about hierarchical methods and density-based methods, and cluster analysis and outlier analysis. So let us first see what is the mean by clustering. So it helps into classification. Clustering majorly helps in classification, and it reduces the amount of data by categorizing and grouping similar items together. So, and also it helps to partition the data into distinct subgroups or clusters such that observations belonging to the same cluster are very similar. This is what it is, the base objective of the clustering. So first, what is the literal meaning of cluster? So the group of objects that belongs to the same class. I'm just going to group it. So classification, if I have a list of items, I'm going to find out in which class it is going to belong to. But clustering is grouping all the similar items into one group, one class. Is called as a clustering. So in other words, if I just take, it is going to be similar objects are grouped into one cluster, and dissimilar objects are all being grouped into another cluster. So clustering is the process of making a group of abstract objects into a class of similar objects. So that is, I'm grouping all the similar objects. So clustering is going to, we should have these things in mind always. So there is a cluster of objects can be created as one group. While doing clustering analysis, we first partition the set of data into groups based on their data similarity and then assign a label to that group. So the main advantage of clustering over classification is that it is adaptable to change and helps single out useful features that distinguish different groups. This is what we have it as a clustering advantage of clustering over classification. So now we are going to see what are all the applications and requirements of clustering. So clustering analysis is broadly used in many applications such as market research, pattern recognition, data analysis, and image processing. So clustering can also help marketers discover distinct groups in their customer base. Say, when I'm going for marketing research, so when I have a group of customers, I want to find out the cluster of similar, there is a who and all is related. Say I'm having an employee or I'm having group 1,000 customers. What are all I want to group all the customers who are willing to buy computer goods every month. So I'm just going to cluster into one group. Those persons who are not going to frequently buy the products, I can have it as one more group. Those who will not at all get, I can have it on another group. So this is what is called as clustering. And then pattern recognition, same pattern. So I'm just going to have, so those are all who can talk in Hindi, those who all can talk in say some example like Madurai slang, Coimbatore slang, Chennai slang. So I want to have some pattern. Based on the pattern, I'm going to have the clustering. That is another thing. So clustering can help marketers discover distinct groups in their customer base, and they can categorize their customer groups based on the purchasing patterns. So when we take in the field of biology, it is going to derive plant and animal taxonomies, categorize genes with similar functionalities, and gain insight into structures. Some of the other applications also is of clustering also helps in identification of areas of similar land use in an Earth observation database. It also helps in the identification of group of houses in a city according to house type. Say, for example, those with the duplex house, those with the uh, permanent ceiling, those with false ceiling. So like this, I can identify and the geographical locations, whether it is a northern area, southern area. So like that, I can just find out the geographical locations also. It results again a clustering. So clustering also helps in classifying documents on the web of information. So clustering also helps in classification of documents on the web of for information discovery. So, so you'll be identifying the documents, which whether it is going to be a document of category, say text document, or whether it is going to be a voice document. So you'll be identifying the cluster based on that. And again, even the text document, you can identify whether it is going to be, say, I'm having a set of notes, whether it is related to computer technology, computer networks, or computer data mining, or whether it is going to be related to IoT. So I'm going to cluster it. So that is also called as clustering. And the next one, the clustering is also used in outlier deduction applications such as deduction of credit card fraud. So whether it is going to be, I'm having, if for example, all the HDFC bank starts with some particular digit, or the branch bank will have a digit, and then the branch will, where in which branch it is being issued. So based on that, it will be having the next four digit like that if I have. So I can now find out if it is not in any of the ranges of any of the bank, then it is going to be a fraud credit card. So I can identify this is how this one is called as the outlier deduction one. And then it is serves as a tool to gain insight into distributions of data to observe characteristics of each cluster. So it is going to identify the characteristics of each cluster. So on the main requirements, what are the requirements of clustering? So the first one is the data scalability. So why clustering is required in data mining? So these are the points we have. So the first one is called as the scalability. What is mean by scalability? It can deal any size of data set. The database can be of any size, that is called as the, so whether it is a small database or it is a very large database, so it deals with that one. So the clustering algorithms deals with that. And then when I have the uh, different kinds of dealing, different kinds of attributes. So I can have a data which is going to be numerical, or it can be something like a binary value, or it can be something like a document, something like that. So I can just have different type of attributes. I'm going to categorize it. It deals with the ability to deal with different types of attributes. And discovery of clusters with attribute shapes, that is the clustering algorithm. It should detecting of clusters of arbitrary shapes. So even I can have different shapes. So I'm having a circle, I'm having a cube, I have having a I'm having a triangle, so something like that, and or some other shapes also. I'm able to have a cluster them also. That is called as the thing. And dimensionality, high dimensionality. So the clustering algorithm is able to handle different things. Say I'm having not only the rows and columns, I can even go for multi-dimension array of data. Say I'm going to have records of a class, a record of a student, marks of a class. It will be having the rows and columns. When I go for an institution, it will consist of many classes, and each class will have marks. So when I go for all the institutions, then I'll be having each institution. There will be many institutions, and each institution will have their own classes, and each class will they have their own marks. So like this, I can going to have multiple dimensionality and the ability to deal with noisy data. That means the database consists of some unwanted data or some missing data. So sometimes it will be having some null values or something like that. So or some erroneous data. So it has to identify that and it has to deal with that. So that is called as the ability to deal with noisy data and interpret Interpretability. What is that interpretability? It is going to should interpret some values. It just has to comprehensive and it should be usable. So these are some of the requirements that I am having with the clustering. So now we are going to see about the major clustering methods. So there are various methods like partitioning method, hierarchical method, density based method, grid based method, model based method, and constraint based method. We'll see one by one. So the first one is called as the partition method. So when I have this partition method, I'm going to suppose, say for example, I'm going to have a database of set n object, and the partition method consists of k partitions. So what will happen? This will be uh, taking each partition will represent a cluster, and k should be less than this. The number of partitions should be less than the number of objects. So that means we can classify the data into three groups which satisfying this. Each group consists at least one object. So that means as we have the k, that is the number of partitions less than the number of objects. So each group should at least contain one object. Each object must belong to exactly one group. It should not belong, it should not have some interaction that is, it belongs to many more than one group. So that should not be there. And it is going to have given the number of partitions, say k. Now the partition method will create an initial partitioning. Then it will have, and say that means it will have, first it will have this iteration, that is it will be partitioned into two strings, like as we have it as by in the binary search. We are having the middle element we are finding, and we are having partition like the upper limit and upper half and the lower half, like that. It will have some partitioning, and it will repeat the same iterative relocation technique to improve the partitioning by moving objects from one group to the other. So like this, it will be doing. That is the first one. So it will be partitioning. So first it will be randomly having the elements in the partition, and it will relocate the element in the iterative process, make them into the corresponding cluster. And then the next method is called as the hierarchical method. So this method creates a hierarchical decomposition of the given data. So we can classify hierarchical methods on the basis of how the hierarchical decomposition is formed. So we are having two approaches here. So the first one is called as the agglomerated approach, and this second approach is called as the divisive approach. So the first approach, agglomerative approach, in this approach, it is called as the bottom-up approach. So we start with the each object forming a separate group. So I'll be having n form n objects, each forming a separate group. Then I'll be merging the objects of similar into one group. Say I'm having all 15 balls in a pocket. I'll have all the 15 balls in a single group, and then I'll merge them. If the second thing, like all balls with the same dimension, with the same radius, I'll just make them into a same category. So that is the next one. And then I'll be going for categorizing based on the color. So next category. So like that, I'm grouping, I'm merging until I'm going to have, I cannot have any more clustering, that is, there will be going. This is called as the agglomerative approach. And then the next one is called as the divisive approach, where it is called as the top-down approach, where I'll be having all the objects into the same cluster, and then I'll be splitting that cluster into the, depending on the attributes I'm considering, I'm going to split them into different clusters. Like that, I'll keep on repeating until I get the all the unique objects into one cluster. So this is called as the divisive approach. And approaches to improve the quality of hierarchical. So the two approaches, that is improve the quality of the hierarchy clustering, are those two, this one. And the other two approaches to improve the quality of the hierarchical clustering we have is the careful analysis we have to perform of object linkages with each at each clustering partitioning, integrate hierarchical agglomeration by first using the hierarchical agglomerative algorithm to group objects into more micro clusters and then performing macro clustering on this micro clustering. So this is what, so you'll be having a hybrid mode of this agglomerative and divisive algorithm. And the next one is called as the density based method. So this is the based on the notion of density. So it is going to, the basic idea is to continue growing the given cluster as long as the density in the hybrid neighborhood exceeds some threshold. So we'll be fixing a threshold. So till that it exceeds the threshold, it will be clustering. And then say, for example, that is for each data point at a given cluster, the radius of the given cluster has to contain at least a minimum number of points. So that is what we have it as the density based. Then the next one, we have it as the grid based method. So in this method, the object together form a, there is the objects together form a grid. So there will be a grid. The object space is quantized into finite number of cells that form a grid structure. So the advantages of grid based method is that the major, it is having fast processing time, and also the number of cells is dependent only on the number of cells in each dimension of the quantized space. So this is about the grid-based method. So next we have is called as the model-based method. So the model-based method, in this method, a model is hypothesized for each cluster to find the best fit of data for a given model. So in this method, we locate the clusters by clustering the density function, and also it reflects spatial distribution of the data points. Then we go for this k-means clustering method. So what is mean by k-means? I'm just going to have k-means clustering is a simple unsupervised learning. There are two categories learning algorithms, like supervised learning algorithms and unsupervised learning algorithm. So k-means clustering is a unsupervised learning algorithm. So developed by McQueen in 1967, and then by Harrigan and Wong in 1975. So in this approach, the data object are classified into k number of clusters, in which each observation belongs to the cluster with nearest mean. So we'll be finding the mean value, so which is having the nearest mean, so it will be into that cluster. So it defines k sets, that is a point may be considered as the center of one or two dimension figures, and one for each cluster, that is k is less than or equal to n. So the clusters are placed far away from each other. So then it organizes the data in appropriate data set and associates to the nearest set. If there is no data pending, first step is complicated to perform. In this case, an early grouping is done. So before that before the itself, it will be clustering. It is necessary to recalculate k new sets of as very centers of clusters from previous step. So after having the k new sets, the same data set points and the nearest new sets are bound together. So this is how it has been done. And then finally a group loop is generated. So again, we'll repeat the same process so that we are getting the k sets change their location step by step until no more changes are made. This is how it is done. So it will be having minimizing an objective function. So that is j. So we'll be having x of I is nothing but the data point. The cluster center is Cj. The number of data points is n. The number of clusters, we have it as k. So we're going to make that mean value. So we're going to find the distance of these two, data point and the cluster, and which is minimum. So that is how I'm going to have the cluster. So this is how it is performing. So number of clusters, I'm having it as say k. So I'll find the centroid. I'll find the mean between the centroid between the p cluster and the data point and the mean, and then data point and the cluster center. So it will be finding, and then it will be finding the distance. So based on the minimum distance, it will group. So again, it will repeat the same process until there is no more change in the group. Then I'll be, if there is a change in the group, I'll again find out the minima. Again, I'll find out the centroid. If there is no change with the group, I'll be going for finding the elements. So I'm having here the set of values. So I'm going to have them into two clusters. So I'm going to segregate. So what I'm going to do, I'm going to have a solution. So first step, I'll have these two sets. I'm going to cluster randomly. So I'll be having two sets, say K1 is equal to 2, 10, 3, 30, and 25. I'm going to find the mean of this. So I'll have to add all these things divided by 5. So I'll be getting a mean value. Then again, K2, I'm having 5 elements randomly I've taken, and then I'm going to find the mean. So I've got a value. So again, assign the values. There is I'm going to again cluster it. So that is, I'm going to get the first from the random value. Again, I'm going to take some random values. So I'm taking 3. So the mean of this one will be 25. And I'm having one more cluster called as K2. I'm going to find it out. So with this mean, I'll again group it. So like this, I'll go for, again, I'm taking a random value. So like this, I repeat, and I'm going to get the mean value. So if the mean value doesn't change, I'll be stopping it. And then the second method, we are going to have randomly, I'm going to have M1 as 3, means I'm just assigning M2 as 4. Now I'm going to take K1 with 2 elements and K2 with 2 elements. So the mean is 2.5 and 16. So what I'm going to do, I'm going to take one more element, and here I'm going to have the same. So I'm going to find out the M1 value and M2 value. So like this, I'm going to repeat, and at the last clustering, when I'm adding elements, I'm finding out that I'm having the same mean 1 and mean 2. So that means I'm not going to have any different changes. So I'm going to have the clusters as 2, 3, 4, 10, 11, 12 or one cluster, and 20, 35, 30, 25 are in the other cluster. So like this, I'm going to have this one. So now we are going to see how to find the algorithmic step of K periods. So I'm going to have select K random points out of the N data points at the periods. Associate each data point to the closest periods by using any common distance metric method. So we are having different metric methods. So I'm going to have a common distance metric method. And then while the cost reduces for each meteor M, for each data point, which is not a meteor, swap M and O associated each data point to the closest meteor, recompute the cost. So we're going to recompute the cost. If the total cost is more than the previous step, undo the swap. Else we can going to repeat the process. So this is how I'm going to have it. And we are going to see the next topic as cluster analysis and outlier analysis. Cluster is nothing but a collection of data object. So we're going to have similar objects. That is what as we have already know. With a similar things are all will be grouped into one cluster. Dissimilar all will be into another cluster. So cluster analysis is nothing but as finding similarities between data according to the characteristics found in the data and grouping similar objects, data objects into clusters. So we are having unsupervised, so no predefined. So we are not having any classes like this is the these are the variation. These are the classes like that. Will not have anything. So when I go for shapes, I'm having the predefined shapes like the rectangle, triangle, like that. But when I go for some other example, say for example, the group of customers, I cannot pretend what type of customers can be grouped. What are all the various categories will be there. So no predefined classes. So we're going to define it. So typical applications are as a standalone tool to get insight into data distribution, and also as a pre-processing step to another algorithms. So the other applications are pattern recognition, spatial data analysis. So we are going to have the thematic maps in GIS. There's the geographical information, geographical things, GIS, and by clustering feature spaces. And we are going to have the um, in geography information system. So, and also we are going to have the direct spatial clusterings or for avoiding spatial mining tasks. And in image processing, it is also having an application. And then economic sciences, market research, as we've already discussed. And then in the World Wide Web, document classification. We can have different types of documents. So as we have discussed this also, so I'm not going in depth. So the customer weblog data to discover the groups of similar access patterns. So some of the other examples of clustering applications, like we are having the marketing, so help marketers discover distinct groups in the customer bases. So as I already mentioned to you, so what are all the different type of customers, whether they'll be frequently buyers, say when I go for this Flipkart or something like that, how frequently they are buying the products. So I'll be categorizing based on their frequency of purchase, the type of data, the type of item they purchase. So like that we'll be categorizing. Then land use, identification of areas of similar land use. So that is I'm going to have whether it is going to be a place where like if I look for agriculture, I want to find whether what are all the similar types of lands which where I can crop a land, I can cultivate what crop. So like that I can go for finding out the cluster. And then I'm going to have the insurance. So identifying the group of motor insurance policy holders with the high average claim cost. So I can find out what is the what type of insurance policy you are having. So I can just cluster it. Density planning, identify group of houses to their house type, values, and the geographical locations. Earthquake studies. So we are going to observe the earthquake epicenters should be clustered according to the continent faults. So these are some of the applications I'm having. So I'm just going to give you uh, the overall uh, summary of that this particular session. So clustering is nothing but the cluster analysis is a type of unsupervised learning technique used to find used to find commodities and commonalities between data elements that are otherwise unlabeled and uncategorized. The goal of clustering is to find the distinct groups or clusters within a data set. Hierarchical clustering is based on the top to bottom approach hierarchy of the data points, and partitioning method is based on the centroids and data points are assigned into the cluster based on its proximity to the cluster centroids. Thank you very much.